Hello everyone. Today we're going to go ahead and find a range in the interquartile range for the following set of data, and we're also going to check to see if there are any outliers within this data set. So the first thing that we're going to do is go ahead and find a range. Now the range basically tells us to go ahead and subtract or find a difference between our largest number and our smallest number. So our largest number happens to be 57 and 25. So we're just going to go ahead and subtract those two numbers, 57 minus 25. And that's going to go ahead and give us 32. Now what that means is that if I were to put all of these numbers, this information, the data, 25 all the way through 57, if I put that information on a number line, the numbers 25 and 57 is being separated by 32 units. So that's what that range means. Now what we want to do is find the interquartile range. So the interquartile range, we can go ahead and say is IQTR for interquartile range, and there are some people that abbreviate it as IQR. To find the interquartile range, that means we need to go ahead and take our upper quartile and we need to subtract it with our lower quartile. Now, that means we got to find out what is our upper quartile and what is our lower quartile. To find that out, we need to go ahead and find our median. Now, the median means the number in the middle, and the number in the middle happens to be this 35 right here. So this is our median. Now, when we find our upper and our lower quartile, we actually never include the median. So what I'm going to do is I'm going to cross this out. Now, the upper quartile means the median of the upper half, or the upper set of numbers, or the larger numbers in this case. So that means from 35 all the way through 47. Now, notice I did not include the 35 that is the median. I never include the median when finding the upper or the lower quartile. So I'm going to go ahead and find the upper quartile by finding the middle, or the median, of that upper half, so from 35 to 57. And the upper quartile in this particular case happens to be between 40 and 41. Now, since it's between 40 and 41, the upper quartile is going to be right in between those, which is 40.5. So that upper quartile is 40.5. Now I need to go ahead and find the lower quartile, which means to find the median of the lower half. So I'm going to do the same thing. Now the lower half happens to be between 25 through 33. So it's the set of data on the lower side, which is our smaller numbers. Now remember, I don't include the actual median when finding the lower half. Now I'm going to go ahead and find the median of the lower half, which means I'm going to find the middle between 25 and 33. And the middle number between 25 and 33 is between 30 and 30. So the lower quartile happens to be 30 as well. So that means my lower quartile is 30, my upper quartile is 40.5. If I subtract the two, that's going to give us our interquartile range, and our interquartile range in this particular case is 10.5. So I found my two measures of variations, which is the range and the interquartile range. Now what I want to do is to check to see if there are any outliers within this data set. Now, if you're not sure what an outlier is, remember an outlier is something that is really, really, really big or really, really, really small, and it doesn't quite fit within the rest of the data set. Now, what is the boundary lines of what is something really big or really small? And outliers are any data that is more than 1.5 times the interquartile range from the quartiles. Now, that means we have two cases since we have two quartiles. So we want to go ahead and check to see if we have any outliers. So I'm just going to go ahead and write down outliers with a question mark here. So are there any outliers? Now to go ahead and do this, I'm just going to go ahead and follow this rule, which it gives us right over here. It says it's basically 1.5 times the interquartile range from our two quartiles, the lower quartile and the upper quartile. So I need to figure out what is 1.5 times our interquartile range. So that means I'm going to do 1.5 times our interquartile range. Well, our interquartile range is what we found over here, so that's 10.5. And if I go ahead and multiply those two together, 1.5 times 10.5, that's going to give us 15.75. Now 15.75 doesn't tell me that that's the outlier. That's going to tell me where my outliers might be. So again, we have two cases here. So we have two cases here where we're just going to go ahead and call it case 1 and case 2. So I'm just going to go ahead and write down case 1 over here. And case 1 is going to check to see if we have any lower outliers. Now, we could probably eyeball it over here, and we could see that we probably don't have a lower outlier since this 25 is really close to that 26. But I'm just going to go ahead and write it out just to see how we find a lower outlier. So what I'm going to do, it says it's away from that quartile, so that's my lower quartile. So I'm going to go ahead and do my lower quartile minus what we just found, that 15.75 right over here. We're going to subtract 15.75. That's going to check to see if I have any lower outliers. Well, I do know what my lower quartile is. My lower quartile, we stated earlier, was this 30 right over here. So that means I'm just going to do 30 minus 15.75, and whatever that gives me is going to check to see, it's going to tell me what I have as my outliers, or the boundary of my outlier. So if I go ahead and do the math, 30 minus 15.75, that's going to give me 14.25. Now that 14.25 basically means anything less than 14.25 is an outlier. So I'm just going to write a little note to myself. Anything less, let me fix that really quick. Anything less than 14.25 is an outlier. So I don't have anything less than 14.25. My smallest number is 25. So I don't have any outliers on the lower half. Now I'm just going to go ahead and check to see if I have any outliers on the upper half. So let's go ahead and do case 2. So this is going to check to see if I have any upper outliers. I'm going to do basically the same thing, except it's slightly different. In the lower quartile, or our lower outlier, what we did is we did our lower quartile minus 15.75. In this case, we're going to take our upper quartile, and instead of subtracting, we're going to add 15.75. So the same number that we found over here. So 15.75. And if I go back to what we found our upper quartile, that was 40.5. So that means I'm just going to take 40.5 and I'm going to add 15.75. And when I add those two numbers, that answer is going to tell me what is the boundary line of my upper outlier. And when I do 40.5 plus 15.75, that's going to give us a total of 56.25. Now this 56.25 basically means anything more or greater than, anything greater than 56.25 is considered an outlier. So now I'm going to take a look at my data set, and I'm going to ask myself, is there anything that is greater than 56.25? And I do see one. That number 57 is greater than our 56.25. So therefore, we can say that this right here is an outlier. So what we did here is we went ahead and checked to see if there was an outlier, and we did in fact find one. And sometimes it's really hard to tell because that 57 does look kind of close to that 50, but we had to go ahead and make sure. So in order to do that, we did 1.5 times our interquartile range. We figured out that was 15.75. And we had two cases, the lower quartile minus that 15.75 and our upper quartile minus or plus our 15.75, and that'll help us find what is our outliers. I hope this helped. Good luck, enjoy, and have fun.